Hi there. So I have a nice little number theory problem for you. So we have a sequence. It goes like 1, 11, 111. So it just goes up like this for arbitrary n digits. And we are supposed to find how many perfect squares are here. So first of all, well, yeah, one is perfect square. But for the next stuff, so if I don't know what is n, and it's not asking me like how many, well, yeah, technically it could be like, for example, n over 2. Like it could be a crazy answer like this. But we will try to show that if there are no perfect squares here, okay? So I'm just gonna try to write this general term. So this thing, 1, 1, so up to 1. So this is n digits, okay? This is gonna be equal to 1 plus 10 plus 100. So it will just go like this up to 10 to the n, but if I say n, it will be n plus 1 digits. So 10 to the n minus 1, which will be 10 to the n minus 1 over 10 minus 1, which is 9. So I want to see if there exists an m such that this is just equal to m squared. So if this is a perfect square, okay? So if I just multiply both sides by 9 now, so 10 to the n minus 1 is equal to 9m squared, and 9 is also a 3 squared, so I can just take 3 in square parentheses, so this will be 3m squared. Okay, cool. So basically, like I said, I want to find a contradiction. I want to see that if this is impossible. So, well, the general strategy can be just working with modulos. It's the easiest way, but it may be hard to find which modulo. So here we can just start from 2. We can just think from 2, okay? So I will just calculate x and x squared for any x modulo 2. So x can be 0 and 1. And so its squared is also 0 and 1. Well, 10 is just gonna be 0 modulo 2. So if it's 0, well, this will be minus 1, which is equivalent to 1 modulo 2. So this will just be 1, and x squared can be equal to 1. So if I say this is x, there is no problem. So instead, if I think wait, let's say this is x. So if I think modulo 3, this will 10 is 1 modulo 3. So this left side will be 0, and of course it can be 0. So let's think modulo 4. So my numbers can be plus minus 1 and 2. If I square 2, it will be 0. And now, so 10 is congruent to 2 modulo 4. So I will have 2 to the n minus 1 being congruent to, so this time I didn't put equal because we are working modulo 4. So this is just x squared, which can be 0 or 1. So I will say 0 and 1. So this means it's either this or this, okay? Modulo 4. And so in the beginning, I excluded the case where n was equal to 1. So this is just same. If I put n is equal to 1 here, it's just going to give me the first term. So here, if I exclude that case, I can say that n is greater or equal than 2. And if n is greater or equal than 2, this will be just multiple of 4. So this thing will just be 0. So I'm going to have minus 1, which is actually just 3, congruent to 0 or 1. And this is obviously impossible. So this is the contradiction that we concluded. And so this means that there can't be such m that this thing is just equal to m squared. So there are no perfect square except for the 1. So the answer is 1, which is 1.